Hey guys, I wanted to go ahead and give you a copy of the explanation for this problem that I had cut out of the quiz. And I cut it out because I wanted just to remind you of some algebra that you can use. So we're finding the absolute maximum of the following absolute maximum of this absolute value equation from -4 to 4. So first thing we want to do is take the derivative. And the derivative of an absolute value function is what's inside over the absolute value itself, du, which is 2x minus 1. So again, it's absolute value of u, the derivative of the absolute value of u is u, which is this guy, over the absolute value of u times du. And since we are finding the absolute maximum, we're going to go ahead and set that derivative equal to 0. So 0 is equal to all this stuff, times 2x minus 1. Okay? Now, let me fix this. Since we are multiplying, we can go ahead and write that with parentheses there. We can start solving by multiplying by the denominator on both sides, which gets us to 0, equal to x squared minus x minus 12 times 2x minus 1. Now I did that by multiplying by the absolute value on both sides, and that gets rid of the denominator. Now this is where I was worried some of you would, right here, I was worried some of you would freak out and try and distribute this out and work with a cubic function that you can't factor. And if you have a cubic function that you can't factor, the only way to get the zeros is to do synthetic division. But if you don't know any of the zeros and you can't use a calculator, like that's just a nasty spiral mess that you would get into. So I want you to notice though that something times something is equal to 0. Something times something is equal to 0. There's a property that says if AB is equal to 0, then A equals 0 or B equals 0. Remember that? So from right here, instead of foiling it out, you can find your critical points by setting x squared minus x minus 12 equal to 0 and 2x minus 1 equal to 0. Now I can factor, and I'll get two critical points out of here, which are -3 and 4. I'll get a critical point out of here, which is 1/2. And so that means I'll have CPs at, like I said, -3, 4, 1/2, and let's not forget our endpoints. So this already is over here. So I'm just missing -4. So these are the locations for possible maxes and mins. So you will put those into f of x into the function to check the y values and see who is your absolute max. I hope that helps. Bye.